Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +2348085095144 to learn more and get started today.
This is called work energy principle. You use it to calculate any kind of relationship that has to do with energy changes, which could be from potential energy to kinetic energy, or from kinetic energy to potential energy. Like this question I gave you. This is the object. That's the box. You know, work itself is what, first of all?
Huh?
Work itself is what?
Like the equation.
The definition of equation, yes, equation.
Force times perpendicular distance.
Are you sure? Perpendicular distance? It's
Yeah.
not momentum. Work.
Force times distance.
Force times distance moved in the direction of the force, right?
Yes.
Force times distance moved. Which one is perpendicular distance, by the way? So that you don't mix it up.
Perpendicular distance.
When do we use perpendicular distance?
Moment.
Moment, okay. So work is force times distance moved in the direction of the force. You know? Distance in the direction of the force. Alright. So work is force times distance moved in the direction of the force. You know that. So in this particular question, just like you were reasoning out, let me zoom it in a bit at my end. This box is resting on this surface, and a force of 30 Newton is applied at 10 degrees to the plane. You seeing that?
Yeah.
The mass of the block is 5 kg, and the box is moved from rest to a point 3 meters up the plane. Find the total work done on the box by all forces. By all forces. The coefficient of friction of this plane is 0.08. Why we are discussing coefficient of friction is because as you are moving it up the plane, frictional force is acting on it too. Let me give you an explanation of what I mean. If you have an object here moved from here, for instance, to here, you know, from position A to position B, perhaps how many meters apart? 5 meters apart, and a force of 50 Newton is applied, and then there is the frictional force which is acting on this surface is 20 Newton. What's the total work done? To move it from A, or from point A to point B.
Okay. And then
The driving force is 50 Newton, the frictional force is 20 Newton. So I said the work done, or the total work done is
50.
look at this. You read this. Read this what I'm saying.
Total work done by all forces in the direction of motion minus total work done by resisting forces.
Okay,
It's
so
like 50. So that's 100 minus 20 times
Yeah. Anytime you are considering total work done, it is the total work done by all forces in the direction of motion minus the total work done by all resistive forces. That is the forces in the opposite direction. So from what you said, the only force acting in the direction of motion is the driving force, because it is moving from left to right. So, and work is force times distance in the direction of the force. So force times distance. So like you said, 50 times 5. Total work done, work total is equal to 50 times 5 minus the force or work in the opposite direction, that's 20 times 5. So this should give us 250 minus 100, as you said, which is 150 joules. Okay, all I just need you to know is this important formula. Total work done in a system is equal to total work done by all forces in the direction of motion minus total work done by all resistive forces, that's in the opposite direction. Okay, now look at this. Can you see the equation I circled? It hasn't circled at the end.
No.
V squared equal to u squared plus 2as.
So I know that equation. That is mathematical.
Yeah, v squared equal to u squared plus 2as. I want to show you a trick we normally use to derive an important formula that you're going to be using for energy changes. V squared equal to u squared plus 2as. If you make v the set of formula, v is equal to, or v squared minus u squared equal to 2as, isn't it?
Yeah.
Okay. Now, you know A itself is F over m. Acceleration is force over mass now.
Yeah.
From this Newton's second law, from F equal to ma. A is equal to F over m now, isn't it?
Yeah.
All right. You just watch me as I derive something. So v squared is equal to u squared plus 2as, or v squared minus u squared is equal to 2as, and a itself is F over m from Newton's second law, F equal to ma. Substitute into 2as, you're going to have 2F over m times s. Isn't it?
Yeah.
Okay, multiply all through by half m. You may be wondering why I'm multiplying all through. It's just a way of manipulating the equation to derive a formula. Whenever you have an equation, if you multiply the equation through by anything, it doesn't change the equation. This is basically what I'm saying. If I have 5x minus 2 equals 8. By the way, what is x? Just an example. What's x in this question? 5x minus 2 equal to 8. What is x? Please, I stay with me. I want to explain something to you. 5x minus 2 equal to 8. What is x? X is 2. Okay, please try and multiply all through by 2. Multiply all through by 2. It doesn't change the equation. The equation still stays valid. If I multiply everything by 2 times 2 will give us 10x minus 4 equals 16. It's still valid, isn't it?
Yes.
Okay, basically what I'm telling you is if you multiply an equation by or divide by something, it still stays valid, because 10x is, you said x is 2, because 10 minus 2 is 8, yes. If x is 2, 10x is 20, 20 minus 4 is still 16. If you divide by 2, you will get back this. If you multiply by 3, it will still stay valid. Okay, that point is just to tell you that what I was asking you to do does not invalidate the equation. And this is what I'm asking you to do. From v squared minus u squared equal to 2as, which is equal to 2fs over m, multiply through by half m. Multiply each of these things by half m, each by half m. V squared by half, pardon?
Half m.
Yeah, multiply this equation by half m.
I don't understand. Divided by m.
Each term multiplied by half m. You remember how we came about this equation?
Divided by m.
Pardon?
What do you mean half m?
That's the half m. As the half m I'm circling.
Oh,
Yes, I want us to derive something. So that even if you forget, you will know how to derive it. It's a formula.
that's 1 over 2 m. 1 over 2 1 over 2 m b squared minus 1 over 2 m squared equals to m as plus
Equal to, remember you are multiplying everything by half m. If you multiply this one by half m, what will be left will be fs.
yeah, that's
Okay, so all of that is to tell you this equation has changed to this. The left hand side itself is changing kinetic energy, is it not?
yeah.
The left hand side is changing kinetic energy. So change in kinetic energy is equal to work done, because Fs is force and distance, which is work done. That's the formula. Change in kinetic energy is total work done. Take note of that. We'll be applying it. Change in kinetic energy is equal to total work done. Did you hear me?
Yeah.
That is if the object is moving on a horizontal plane where the only energy change is kinetic energy. Let me give an example just like I gave for this one. Stay with me, all of these things will add up because you need to have that foundation. But whichever way the question comes, you'll be able to deal with it. Look at this simple illustration. This object started with a speed of, initial speed is 20 meters per second, and after the speed changes to 5 meters per second. The mass of the object is 20 kilograms. What's the work done? Back to the formula. Change in kinetic energy is equal to work done. Change in kinetic energy is total work done. So the total work done is basically the change in kinetic energy. And what's the change in kinetic energy here?
Alpha.
So total work done. Change in kinetic energy. Total work done is equal to change in kinetic energy. Because it's moving on a level ground, which is half mass, and the mass is 20 times 20 squared minus half mass 20 times 5 squared. You have a calculator there. Your calculator, please.
Don't have
You can give me the answer. Did I hear you say you are doing it?
I don't have
Oh, I thought I heard you were working it out. Can you use anyone from your gadgets? Well, this should be easy to work. This 20 squared is 400 times 10. That's 4000 minus. This should be 40000 minus 10 times 25. That's 250 minus 250. That will give us 10 times 25. Yeah, 10 times 25 by 250. 10 times, yeah, that's 250. So this might 4,000 minus 250 give us 3,750 joules. That's the total work done. Okay, now if the object is also climbing a plane as the speed is changing, you need to include the potential energy. This is what I'm saying. When an object starts from a particular speed and moves up a plane, apart from changing its kinetic energy, it also changes its potential energy. Here I am. Are you with me?
Yeah.
Like this object that is climbing up this plane. If you can see where I am tracing,
Okay.
it's climbing up the plane. If the speed is changing, can you tell me the energy changes that are taking place there?
Speed is changing.
So if the speed is changing, tell me the energy change that is taking place as it's climbing up the plane, if the speed is changing. No, not necessarily from one energy to one energy. Just tell me a particular energy that has changed.
The speed is changing. Kinetic energy.
So kinetic energy has changed, and it is climbing up a plane. What else has changed? Can I hear you better?
Gravitational potential.
And also gravitational potential energy has changed. Unlike if it was just on a horizontal surface like this one, where it is only the kinetic energy that changed from u 20 meters per second to final velocity of v 5 meters per second. By the way, this should be a negative work. When you are looking at that, it should be final minus initial. It should be negative. That's sorry, let me write it in the right perspective. 250 minus 4,000, which is actually minus this. It's important that you take note of those signs. It's actually very important. This is why I talked about it. This is why I talked about it. For a special case of deceleration, if something starts with an initial speed of 10 meters per second and changes to a final speed of 7 meters per second, the change in kinetic energy is kinetic energy final minus kinetic energy initial, and of course that will give you a negative value. The signs are important. The signs are important. You don't just, because you will need to use it with other things, so the signs are important. Okay, so the point I'm making is, if an object is climbing up a plane, apart from changing its kinetic energy if the speed is changing, it also changes its potential energy because the height is changing. Alright, so it is not only kinetic energy we consider. We have to consider all those changes. So this is the formula we use for that. Are you there?
Yeah.
Let me point it out. So when an object starts from a particular speed or example rest and moves up a plane, apart from changing its kinetic energy, it also changes its PE. Therefore, it's not only kinetic energy that changes, both kinetic and potential change. And so we need to restructure the initial equation. Read what I'm circling here. The initial equation we got.
Therefore, changing kinetic energy equals to total work.
You saw where we got it from here. Change in kinetic energy is equal to total work done. And I told you how that was proved using simple Sovart equation, V squared equal to U squared plus 2AS. Substitute A with F over M from F equal to MA. Just a quick review. So A becomes F over M. So V squared minus U squared is equal to 2FS over M. And I said multiply all through by half M. So this times half M, this times half M, this times half M. And then we're able to get half mv squared minus half mu squared equal to fs. Half mv squared minus half mu squared, which you have on the left hand side, represents change in kinetic energy, and fs represents work done or total work done. Anyways, it's coming together. So the complete equation, if it is climbing up a plane, is the change in kinetic energy and potential energy, which will be taking place at the same time, is equal to total work done. But then you need to exclude the work done by weight. That should be excluded. Please let's solve this question to prove it, to illustrate this point. We can now solve this question. There's a push with a force of 30 Newton inclined at 10 degrees to the axis of the plane, or parallel to the plane, 10 degrees parallel to the plane. Now the mass of this object is 5 kg, and is moved from rest to a point 3 meters up the plane, and we're asked to find the total work done on the box by all forces. Do you still remember what I told you about total work?
Yeah.
What did I say? What did I say we should do to calculate total work?
Sorry.
Total work done. Work done by forces in the direction of the motion minus all work done by all resistive forces. Total work done is equal to work done by all forces in the direction of the motion
Minus total resistive forces.
minus work done by all resistive forces. Okay, so which force is in the direction of the motion in this case? Only this one, isn't it?
Yeah.
Because it's moving up the plane. So this is the only force that is the direction of the motion. Did you get me?
Yeah.
Alright, what's the value of this? What do you say is the value of this component of the 30 Newton force?
Therefore,
30 cos 10, okay. So that's 30 cos 10. So the work done is 30 cos 10 times the distance. The force itself is 30 cos 10. That's this horizontal component. The angle is 10 degrees. 30 cos 10 times the distance. That's 3, isn't it?
Yeah.
Okay, times 3. That's in the direction of the motion. Now we have forces that are in the opposite direction of the motion. So minus this. This one is opposite the direction of motion.
I can't stand direction.
This one, are you listening? This one now is in the opposite direction to the motion. It's going down the plane. Are you sure? Are you still on the Jamboard?
Yeah.
I said this force is in the opposite direction to the motion. It's going down the plane. What's the value of this? Remember, this is the weight. What's even the weight, by the way?
The weight is 5 kg.
Let's use G equal to 10. If G is equal to 10, just for simplicity, if we're using G equal to 10 Newton per kilogram, so the weight is 5 Newton, right?
Yeah.
That's mass times G. Okay, so weight is 5 times 10, which is 5 Newton, 50 Newton. The weight is 50 Newton because the mass is 5 kilogram times 10, 50 Newton. Okay, so what's the value of this? If you can see what I'm tracing, what's the value of this?
That is
Maybe I should help you a little bit. Let me zoom it in a bit. This angle is 30 degrees, so this angle is 30 degrees. Resolving, I've already helped you to resolve it with the yellow line. What's the value of this force now, acting down the plane? 50 sin 30, good. 50 sin 30, so that's 50 sin 30. Remember, we are looking for all the total work done, and the formula again is work done by all forces in the direction of motion minus work done by all resistive forces, which are of course forces acting in the opposite direction to motion. For this motion up the plane, the question says the box is moved from rest to a point 3 meters up the plane. So the only force acting in the direction of the motion is this component that we got as 30 cos 10. And we have this one acting in the opposite direction to the motion, which you said is 50 sin 30. That's correct, because this side is opposite. All right, there's also friction, because we are told that this is not a smooth plane. It has a coefficient of friction of 0.08. Did you hear me?
yeah.
All right, I'm not sure if you have done that. Frictional force is equal to coefficient of friction times normal reaction. Have you come across this? Have you come across this? What I just wrote now? Zoom down. Frictional force is equal to normal reaction R times coefficient of friction.
No.
Okay. The normal reaction is, as the name implies, the reaction from the surface of the plane, which of course is acting at 90 degrees to the plane. Rn is the normal reaction. And you know this normal reaction, wow, this thing is a bit a little bit complicated, but you should be able to resolve it. I just discovered something, but it's not a big deal. I just want you to observe it. If this thing is in equilibrium, you've done equilibrium. Please listen up. This box is in equilibrium, right?
Yeah.
For it to be in equilibrium the way it is now, total forces perpendicular to the plane must be equal to 0. Let me put it in a simple term. Total forces that are perpendicular to the plane, all the forces that are perpendicular to the plane, resultant forces that are perpendicular to the plane must be equal to 0. You know, for something to be in equilibrium, resultant forces in one direction must be equal to 0. In other words, total forces upwards must be equal to total forces downwards. Total forces to the right equal to total forces to the left. So in this case, total forces that are perpendicular to the plane, the resultant of them must be 0. If you notice, this force is perpendicular to the plane, Rn, perpendicular to the plane. You know what I mean by perpendicular to the plane?
Yeah.
Rn is perpendicular to the plane. This other component is also perpendicular to the plane. And this component I have here is also perpendicular to the plane. Looks like it's a bit tough. It is not. Give me the value of this force. Oh, that marker is not good. This one better. Give me the value of this force I'll label now.
Which one do you use?
This one I labeled. This one here, this force. You know, it's a component of the weight. The weight.
Is it not 5 feet?
Say that again.
50.
50 cos.
What is it cos? Oh, 50 cos.
50 cos, because you know it's adjacent to the 30 Newton.
Yeah.
This one that was opposite to the 30 Newton, you told me 50 sine. So this one should be 50 cos 30, right?
Yeah.
50 cos 30. Sorry. All right. 50 cos 30. What's the value of this one now? This one. Can you see it? Where I'm pointing at?
No, I can't see well.
And scroll to the left. I'm towards the left hand side. Left.
Okay. Oh, okay.
So what's the value of this force?
That should be 30 cos 10.
Do you mean sine?
Yeah, sorry, sir.
Because it's opposite to the 10 degrees. So this is 30 sine 10. Why can I write it with red so it can come out better? This is 30 sine 10. 30 sine 10. And then the normal reaction. All I'm trying to tell you is this box is in equilibrium. When this box is in equilibrium, this normal reaction must be equal to these other two that are in opposite direction to it. The three forces that are perpendicular to the plane. You know what I mean by perpendicular to the plane? This is the plane. Did you see what I traced?
Yeah.
This is the plane. The three forces that are perpendicular to it are normal reaction, this component of the weight, and this component of the 30 Newton force. 1, 2, 3 forces are perpendicular to the plane. 1, 2, 3 are perpendicular to the plane. One is acting above the plane, which is normal reaction. The other two are acting, in the opposite direction. So for equilibrium, give me the relation between this normal reaction, this component of the weight, and this component of the 30 Newton force. I've said so many things. I'm not sure you saw where I was circling them.
Yes, okay.
Can you state the condition necessary for equilibrium?
Forces in one direction and total
Okay, good. The total forces in one direction must be equal to total forces in the opposite direction, so that the resultant force will be equal to 0. So for forces perpendicular to the plane, it means this normal reaction acting above must be equal to these other two acting in the opposite direction, isn't it?
Yeah.
So normal reaction Rn is equal to what?
Huh?
Just a moment, please. I wanted you to see that Rn, normal reaction, or simply R, if you like, you can call it Rn, is equal to 50 cos 2030 plus 30 sine 10. This is it. These are the two forces. 50 cos 30, this one, that's this, plus 30 sine 10, that's this one, opposite to it, sine 10, adjacent to the 30 cos 30. Okay, so we need a calculator, really. We do. You have to get this one. Is there anything that you can do with the system to calculate this? So that we can start rounding off, please. Geometry. Okay. 30 trigonometry. So 30 trigonometry cos. Yeah, times 50. That gives us 43.30. So this is 43.30 plus sine 10. Sine 10 trigonometry sine, then times 30. 5.21. This one is 5.21. So this gives us 48.51 Newton. Normal reaction is 48.51 Newton. Did you see that? Alright. I did all of that so that I can get the frictional force. Frictional force itself is normal reaction times coefficient of friction. And that question, we are giving the coefficient of friction to be 0.08. And you will need to understand why I'm including coefficient frictional force. It's part of the opposing force. So frictional force is 0.08 times the normal reaction 48.5, and that gives us, let me press it again, 0.08 times 48.51. I think that's what we got. Equals 3.88. It gives 3.88 Newton. Okay, please, the essence of getting the frictional force, back to this diagram. Can you just refer to the diagram? Let me summarize with that. We can start winding down. The need for that frictional force is because we need to find the total work done, and total work done is work done by all forces in the direction of motion minus work done by all forces opposite the direction of motion. The force in the direction of motion is this one we found earlier, 30 cos 10. That's it. 30 cos 10, that's the force in the direction of motion. Then times the distance, 3, the work done. Then we had the one opposite the direction of motion, which is 50 cos 30. Times the distance, which is 3. I have not multiplied that, times 3. Are you there?
Yeah.
Okay, so 50 cos 30 in the opposite direction of motion times the distance 3. Then frictional force is also acting, because when you are moving this thing up, frictional force acts in the opposite direction. Frictional force acts in the opposite direction. If you are trying to move it up, frictional force acts in the opposite direction. That's why I needed to find the frictional force. So frictional force, we found it to be 3.88. So that will also be minus the frictional force times the distance. That's work done. 3.88 times 3. Okay, please, since this is the final place, can I quickly say what I did, why I got, how I got this, all of this, and then we start winding down. Now, I said total work done in any system is equal to work done by all forces in the direction of motion minus work done by all resistive forces in the opposite direction of motion. So for this particular question, the only force in the direction of motion is this yellow one, pushing it up the plane, the component of the 30 Newton force that is parallel to the plane, which we got as 30 cos 10. So that's the force times the distance times 3. So minus all resistive forces. This is a resistive force which is pulling it down the plane opposite the direction of motion, and that force itself is 50 cos 30. So times the distance times 3, minus again the frictional force, because you are pulling it up, friction acts in the opposite direction. So the frictional force, you get it by multiplying coefficient of friction by normal reaction. We have to first we found the normal reaction to be 48.51, and with that we're able to get the frictional force to be 3.88. So that frictional force times the distance too. Alright, so this is what we simplify. If you got this, let me know. Did you get how I came about this? What I wrote here? Okay, please let me work it out. 30 cos 10. This is 10 cos 10 cos 10 times 30 equals minus, I have to open it a bracket, minus sin 30 is half times 25, that's minus 25, then minus, that can be, oh no, okay, alright, okay, I think I'll better close the bracket now. Then how do I delete now? Okay. Can I delete? It's not deleting. Okay, minus. I needed to close that bracket. Okay, this first one is 29.544. Okay, 29.544. No calculator, so we are stopped. 29.544 minus 25 minus, let me do 3.8 times that. So 3.88 times 3. That gives 16.18. 16.18. 16.18. Alright, so I can now do 29.544 minus 16.18. That gives 13.69. So the total work done is 13.69 joules or 13.6 joules. 13.4 to 40. 3 single figures. Did I lose you?
No, I'm still here.
Okay. So this one I circled is to help us get the frictional force. So to help us get this, which we used to multiply by 1. Okay, so that's how to use that first formula to get this. And they asked the question, calculate the speed of the box when it is 3 meters up the plane. The second part of the question. We've done the first part, find the total work done. Now calculate the speed of the box when it is 3 meters up the plane. This one we have to apply the other formula. That other formula is total kinetic energy plus potential energy. Total, this is for B, the B part of the question. The A, we are done with it. I think I will just end with this. I have to. Total KE plus PE, which is together KE plus PE, together are called mechanical energy. So total mechanical energy is equal to total work done. But I have to add a caveat, a warning. Total work done. When you are applying this formula, I told you that you should not include the one by weight minus the one minus work done by weight. I will refer you to that, minus work done by weight. You cannot add the one done by weight when you are applying this formula. I showed you in the previous, that was page what? Page 6. Can you just go there, let me refer you to it, and then we'll move forward.
Yeah.
I said it. Total kinetic energy plus potential energy is equal to total work done by all forces total done by work done by all forces, weight and the component of the weight. What is the total work done excluding, removing that of weight, excluding, it shouldn't be added. So you can also see it here. Total kinetic energy plus potential energy, you see it on the left hand side, is equal to total work done by all forces minus, of course, and then you must remove the one done by weight. Okay, just so that you will understand it, let's complete the work we're doing.
No, I thought this was over.
I wanted to solve that B so that you see how we apply that to find the total energy. The question asks, go to that page 10, I can finish it quickly. Page 10. Calculate the speed of the box when it is 3 meters up the plane. And I said this total kinetic energy plus total potential energy is equal to total work done, excluding the one done by weight. So let's just apply it. So total kinetic energy is equal to half mv squared minus half mu squared. That's for kinetic energy. Change in kinetic energy. This is change in kinetic energy. Plus change in potential energy, which is mg at a particular height minus 0, if you like, just mgh. Okay, is equal to total work done. Total work done, excluding weight, that of weight. Okay, so half mv squared, because the question is asking us find the speed, calculate the speed. It started from rest. The box moved from rest, so initial speed is 0. Find the speed at 3 meters of the plane, so which is v. So let me just apply it here. So I have half times the mass is 5 times v squared, we don't know, minus half times the mass is 5 times initial speed is 0, so 0 squared is 0, so that will not change anything. That's the change in kinetic energy plus change in potential energy. That's the one you need to know what it is. I think I have to conclude this by myself. You need to know this height. Are you there?
Yeah.
What's this height? This whole place is 3 meters. It said it moved off the plane by 3 meters at an angle of 30 degrees. So what's this height? This height I'm shading by trigonometry ratio.
Cos 3 cos.
3 cos. 3 sine. It's opposite of it.
No, sorry, 3 sin
3 sine 30. So that height is 3 sine 30. So h is 3 sine 30. 3 sine 30 degree, that's the height. So plus change in kinetic energy and potential energy is mass 5 times g 10 times height 30. Okay. All right.
Yeah.
Then this must all be equal to total work done, excluding weight. We already know the work done by this one is 30 cos 10 times 3. I write it very quickly. 30 cos 10 times 3. The only opposing one is friction, because it says we should not consider that of weight. So we are not considering this one. It's only frictional force we consider. And the frictional force we got is to be 3.88. Is it? The frictional force 3.88. So minus 3.88 times 3. Alright, so we have the equation now. Okay. So half times this will give us 2.5 v squared. What I solved is this. 2.5 v squared minus 2 times, okay, this is 0. So this whole place is 0. So it doesn't make nothing to do with it. So 2.5 v squared, if you like, minus 0 is equal to, oh, I should have written sine 30 here, I forgot. Was it sine 30? Yeah, sine 30. Because, oh, 5 times 10, oh, times what? MGH. Oh, 3 sine 30. 5 times 10, that's mass is 5, G is 10, H is 3 sine 30. You are not helping me. I was making a mistake. You didn't discover that. It's 1.5. Sine 30 is half. 3 times 5 is 1.5. Okay, so 5 times 8 is 50 times 1.5. Okay, so it's equal to plus 50 times 1.5. Where's our calculator? 50. I'm just working out that thing. 50 times 1.5. 1.5. That's 75. 75 is equal to 30 cos 10. This is, trigonometry. 10 cos. No. 10 trig cos times 3, then times 30 equals 88.6. That's 88.6. 88.6 minus 38.88 times that. So 3.88 times 3 equals 11.6. So 11.6. Alright, so as it eventually have 2.5 v squared is equal to 88.6 minus 11.6 minus 75. So this will be, I've got to let you go.
Okay. Thank you.
So for this, we can see that v squared is equal to 2.0. 2.v squared is equal to 2.0. So that will give us v equal to 0. Square root of 2.0 over 2.5 should be calculation. That will give us 0.89 meter per second. So that's that. 8.6 minus 11.6 minus 75 will give us about 2.0. So, and 2.5 v squared is 2.0. V is square root of 2.0 over 2.5, which is 0.89 meters per second. Okay, so this is this. There's a mistake here. Or even here. When we're working out this, 30 cos 10 times 3. No, this is not 29. It should be bigger. 30 cos 10 times 3 calculation. That should be 88.63. This is 88.63. 88.63. That's a slight mistake. 88.6 or 63. Then 50 sine 30 times 3. Sine 30 is 0.5. That's half. 50 sine 30 is 25 times 3. 25 times 3 should be 75. How could we have made that mistake? 75. Also, there's another mistake here. 3.88 times 3. 3.88 times 3 calculation. That should be 11.64. Well, we mixed up these things. 11.64. So we can now say 88.6 minus 75 minus 11.64, and that will give us 88.6 minus 75 minus 11.64. That should be 1.99 joules. 1.99 joules. That's the total work done. So we have it all. For the first question, find the total work done on the box. It's 1.99 joules. That's A. A is 1.99 joules. As we just found out, A is 1.99 joules. The second question that says, calculate the speed of the box when it is 3 meters up the plane. We found it to be 0.89 meters per second. So that should be it. This is the where we solved all. And here. We got our final answer from this question. Alright, that should be it. That should be it. Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to two main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.